Part 11 traced a block all the way from to.html down to a real PHTML file rendering. Today we look at a completely different part of the framework that still ends in real PHP objects, the admin grid. Open any admin listing XML file and you will not find a single line of PHP. You will find a dataProvider element with a class attribute, sitting inside a dataSource element, sitting inside a listing element. And yet, somehow, that bare string in a class attribute turns into a live object with a real getData method returning real product rows. We are going to trace exactly how that happens, using the real product grid XML and the real factory method that reads it, every file and every line from a real get checkout of the pin 2.4.9 tag. Welcome back to Magento Development Deep Dive. This part is about UI components, the system behind every admin grid, form, and modal in the backend. We are narrowing the scope deliberately to one concrete question: how does the admin product grid go from a declarative XML file to a real PHP class supplying rows of data? We will trace the real product listing XML, the real factory method that turns a class attribute into a live object, and the real dataProvider class hierarchy that catalogs product grid actually uses base class first, then the concrete catalog subclass, using ground truth line numbers from a local checkout of the pin 2.4.9 tag. By the end of this part, 5 things should click. What a real dataSource and dataProvider declaration actually looks like inside product_listing.xml, not a simplified example. How a bare string sitting in a class attribute in that XML file ends up as a live, constructed PHP object with dependencies already injected. Why UiComponentFactory's create method has a very deliberate override step that lets configuration win over whatever class name it resolved earlier. What the shared AbstractDataProvider class provides on its own, with zero knowledge of products or collections. And how the real, concrete ProductDataProvider class builds an actual product collection and turns it into the array structure the admin grid's JavaScript expects back. Strip away the code and every admin grid goes through 5 stages to reach your screen. Declare, a module ships an XML file like product_listing.xml, with a dataProvider element and a class attribute pure declaration, no behavior yet. Parse, a config reader, part of the UI component config system, turns that XML file into a nested PHP array, the same declarative config pattern the series has already seen with d.xml and layout.xml resolve. The real UiComponentFactory create method we are about to open pulls a class name out of that array, with a specific override rule we will look at directly. Instantiate, once a class name is settled, ObjectManager builds the actual object, running its constructor with real dependencies. And getData, the resulting object's own getData method, is what the admin grid's JavaScript actually calls, over and over, as you scroll, sort, and filter. A few things help before we dig in. Part 3, on dependency injection, is directly useful. ObjectManager building a real object from resolved configuration is the exact same mechanism this part traces, just triggered from a different config file. Part 10, on layout.xml, helps too. It is the same declarative XML drives real PHP objects pattern the series keeps returning to, and this part is really that pattern's cousin in the admin panel. Either a real Magento 2.4.9 checkout, or the GitHub tag open in a browser tab, so you can follow along in the real files. No prior admin grid or knockout.js experience is needed. This part stays entirely on the PHP side of the UI component system. This is the real dataSource and dataProvider block from the actual admin product grid's XML file, trimmed only where marked. The dataSource element names a JS component for the front-end half of the grid, an ACL resource gate, and an update URL the browser pulls. But the piece we care about is the dataProvider element's class attribute, a bare string, Magento /catalog /UI /dataProvider /product dataProvider. Nothing on this page instantiates anything. This is pure declaration, exactly like Part 10's reference block elements were pure declaration until the real generator class did something with them. Columns follow the exact same declarative pattern as the dataProvider element, just one level down. The SKU column needs no PHP at all. It is a plain field name, a text filter, and a label, rendered generically. The price column adds its own class attribute, pointing at a real catalog column class that formats a raw decimal into store currency-aware markup before the grid ever displays it. 2 columns, sitting 3 lines apart in the same real file, and one of them needs a custom PHP class while the other does not. The XML format supports both without any special casing. This is the real create method on UiComponentFactory. The class every UI component in Magento, dataProviders included, is actually built by. It first calls arguments resolver to get a starting class name and a bag of arguments out of the parsed configuration. But then comes the line that matters most for this part: an explicit check for component arguments config class. If the parsed XML configuration carries a class key, that value wins outright, overriding whatever arguments resolver had already picked. That override is exactly how the bare class attribute from product_listing.xml, once parsed into this array, ends up as the class Magento actually instantiates. A few lines later in that same real method, after any child components have been resolved recursively, the actual instantiation happens. ObjectManager arrow create is called with exactly two things: the class name that survived the override we just saw, and the full component arguments array as constructor arguments. This is the exact same ObjectManager arrow create call part 3 covered in general terms, just reached from a completely different starting point. The bare string sitting in product_listing.xml's class attribute is, by this line, no longer a string at all. It is the fully qualified class name of a live object about to be constructed. This is the real, complete constructor on AbstractDataProvider, the shared base class implementing dataProvider interface that every concrete data provider in Magento extends, catalogs included. Notice what it does and does not know about. It stores a name, a primary field name like entity_ID, a request field name, some meta, and some data. Nothing about collections, nothing about products, nothing database related at all. This class's whole job is the generic contract every grid, form, and modal data provider shares. Anything specific to loading actual rows is left entirely to a subclass. This is the real constructor on the concrete class product_listing.xml actually names ProductDataProvider. It calls parent : construct first, satisfying every generic requirement AbstractDataProvider defined a moment ago. Then it does the one thing that class deliberately left out. It takes an injected collection factory, itself built through ordinary dependency injection, and calls create on it to get a real, live Magento catalog product collection, stored on $this arrow collection for every later method to use. This is where a generic UI component contract turns into something that actually knows about products. This is the real, complete shape of getData, the method part 4's diagram scene called the final destination, and it is the exact method the grids.js component pulls through that MUI/index/render URL back in step 1. It lazily loads the collection built in the constructor, only once, converts it to a plain array, and returns exactly 2 keys total records, straight from the collection's own getSize, and items, the actual row data. Every column you saw declared in step 2, SKU and price included, is simply a key inside each one of these item arrays. One more real method rounds this out. getMeta starts by calling the parent implementation, then loops a real, injected modifiers pool, letting each modifier's modify meta method adjust the resulting metadata array before it goes back to the grid. This is the actual extension point third-party modules used to add or hide columns on the product grid without editing product_listing.xml at all. Get a modifier onto this pool, through ordinary dependency injection configuration, and getMeta will call it automatically, every single time this real data provider is asked for its metadata. A few things trip people up here. The class attribute inside a data provider XML element always wins over whatever arguments resolver had already picked earlier in create. If you are debugging why a custom data provider is not loading, check that override line before anything else. A column with no class attribute is not broken or unstyled by accident. Magento intentionally falls back to a generic column renderer, and most columns in a real grid, SKU included, use exactly that path. AbstractDataProvider declares a collection property but contains zero logic for building one. Only a concrete subclass, like ProductDataProvider's own constructor, actually populates it. And getData only ever returns total records and items. Column labels, filters, and options all travel through the separate getMeta call, not this one. Let's pull this back together. Product_listing.xml declares a data provider element with a bare class attribute pure configuration, no PHP behavior at all. UiComponentFactory's real create method has a specific, deliberate override step that lets that XML declared class win over whatever arguments resolver had already picked. ObjectManager's create call is the exact point where that resolved class name stops being a string and becomes a live, constructed object. AbstractDataProvider supplies the shared, generic contract every data provider needs, while ProductDataProvider is the concrete subclass that actually builds a real product collection. And getData together with getMeta are the two methods the admin grid's own JavaScript keeps calling, over and over, as an admin scrolls, sorts, and filters the real product list. That's the real machinery behind Magento's admin grids, straight from a git checkout of the pin 2.4.9 source, every file and line verified against that exact commit. Part 13 moves to the command line building a Rail, custom bin/Magento console command from scratch. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 13.